So Hermes is a system. It plays a couple of different roles. It acts as kind of a clearinghouse or a switch for information from other systems. So it can play a role on its own as kind of a mini systems integration bus or something like that. And Virgin certainly uses it that way. The other thing that it does, however, that's quite different from that and quite important is that it is the channel by which messages from the aircraft directly from the aircraft come into Virgin over a system called ACARS. So ACARS is a very old protocol that's been around in the aviation industry for a very long time. It's very low bandwidth. It uses highly compressed kind of message structures, and basically what it's used for. I mean, it's used for a lot of things, but in this particular case, the one that we're interested in is as an aircraft is approaching, they will use ACARS system to request a landing bay, a gate. Where are they supposed to go once they land? And so what happens is that message goes out from the aircraft over this like radio. Using this ACARS protocol, it gets routed through air traffic control, it gets routed to Hermes, and then Hermes places that gate bay request, they call it, on a queue. And so what we do with that is we subscribe to that queue, we read it into a Kafka topic, and then we have a service which subscribes to that topic and interprets what the structure and content of that ACARS message is. So it's nothing that's industry standard outside of the aviation industry like XML or JSON or something like that. It's quite a specific protocol, which is quite standard in the aviation industry, but outside of aviation, nobody's ever heard of it. So we deconstruct that request, and we figure out what the flight is and what the tail number on the airplane is and what they're asking for and when they need it and so on. And so that's called the bay request. And then what we do, because we have then converted that into a structured stream of data with a little bit of information in it, then we are able to join that once again with the flight state stream, which is the kind of master stream of flight data. And then we are able to, having joined the request to the flight stream, we're able to extract from that joined result, we're able to immediately look up what is the allocated bay and gate for this flight. And then we construct the outbound ACARS message, again, using that ACARS, that curious ACARS format. We construct that, we push it to another Kafka topic, which publishes it to a queue, which Hermes then reads and sends it up to the aircraft. Now, the way they used to do it is they would read the bay requests in. For each bay request, they would then go do a synchronous lookup. First of all, it's coming in over multiple components. When it gets to the end of this long chain of components that are basically doing nothing but copying the message from A to B, it would then go do a synchronous lookup of the flight state to a separate database over here, and then extract the information it needed and then push it back the other way. So once again, as soon as you're in that synchronous world, you've got delays, you've got latency, etc. So the replacement solution is much easier to maintain, it's much simpler, much easier to understand. And yeah, those are probably the principal benefits of doing it that way.